Hey, you tens. Welcome to chapter 10, where we take a look at angles, triangles, and congruence in exercise 10.2. The test will be just on chapter 6 and 10 for this topic. And so the first thing we're going to check out is proofs and theorems. So when we deal with angles, triangles, and congruence, there is a certain method to go about mathematical proofs. So a proof is an argument that shows why a statement is true. A theorem is a statement that can be demonstrated to be true, backed by the proof. So, the following language you need to know, so then you can provide the appropriate information in your working out. So, given, this means provide a summary of the information that's given. To prove a statement that needs to be proven, construction, a description of any additions to the diagram given, proof, a sequence of steps that can be justified and form part of a formal mathematical proof. So before we get to the examples, there's some key, I guess, knowledge that we need to understand first. So whenever we talk about angles at a certain point, the sum of all the angles is 360 degrees. If you think about your compass, a full revolution is 376 degrees. Okay, and no matter how many little lines branch off from a certain point, all these angles, A, B, C, D, E, if it keeps going down to Z, added together will get you 360 degrees. Supplementary angles, on the other hand, are straight lines which add up to 180 degrees. So a straight line is always 180 degrees because it's half of a revolution. And whatever lines branch off the straight line will always add up to 180. Here we have A, B, C. These three angles will add up to 180. The next theorem is, well, vertically opposite angles will have the same degree. Okay, so here we have A and B, they will be the same. And I guess C and whatever this angle here is called, it's not O because the O stands for the origin, will be the same also. So here we have given straight lines A, B, and CD intersect at O. To prove, we say angles AOD equals angle BOC and angle BOD equals angle AOC. To construct this, we label AOD angle AOD as angle BOC as B and angle BOD as C. So what you notice is whenever we got these little, I guess, angle symbols, as we can see here in AOD, the angle that it refers to is the origin. So whatever letter is in the middle, so O here being the origin, is where the angle is being pointed to. So angle AOD, so AOD, so these, the angle on the left here is called A, as they've constructed it here. And then for the proof, you can say let angle AOD equals A degree, angle BOC equal B degree, and angle BOD equals C degree. They all add up to 180 degrees. So really complicated, I guess, abbreviations to learn, but the concept itself isn't so difficult after all. Parallel lines, this is a situation where we have, I guess, a bunch of different terminologies. For example, co-interior. Co-interior angles are supplementary. For example, A and B are co-interior. Okay, they're sort of opposite each other, but not diagonally opposite, meaning, I guess, it'll have to add up to 180 degrees, all right, because this angle here is going to be the opposite angle over here. So let's just highlight this. So co-interior, so A and B. All right, so these two add up to 180 because this angle here of A is the same angle that I'm highlighting right now. All right, but we're not going to leave the highlights because we've got other angles to talk about. Corresponding angles are equal. For example, B and D. So B and D here, they share basically the same corner because it's parallel. Okay, so these two are the same angles. And that's what we call a corresponding angle. Alternate angles, B and C, are equal also because, like we said with A, and the opposite of, well, on the flip side of the transversal line of B, B and C here are basically mirrors of each other, and that's why they're equal. Opposite angles are equal. For example, C equals to D, because they are split by this transversal line evenly, okay, across the parallel lines, which means C and D are going to be the same. Theorem 2. So when we talk about triangles, all the interior angles are going to add up to 180. So A, B, and C, they're going to add up to 180 degrees. Let's ignore these complicated words for now. We'll deal with them in the examples. Here, what it's saying is, I don't know what it's saying. Okay. So this was just an extended proof of why everything adds up to 180 degrees. So if we were to draw a parallel set of lines, D to E and then A to C, where the triangles A, B, C, you can see, well, it all has to add up to 180 degrees based on the parallel lines rules above. So that's sort of the proof. Equilateral triangles, okay, the exterior angles of a triangle is equal to the sum of the opposite angles. So for an equilateral triangle, once again, the interior has to add up to 180, meaning A, B, and C will all be 60 degrees because 180 split evenly 3 times is 60 degrees. Yeah. Ooh, let me just mute my emails. Yeah, and so this exterior angle of D is just going to be 180 take away what angle C is, and that'll tell us what angle D will be because C and D will add up to 180 degrees. Alrighty. Congruent triangles. What I want you guys to highlight, that's really important, is when you hear the word congruent, think the word same. Okay, same or identical. Either will do. All right, and then there's 4 tests for you to. Actually, no, there's 5. Okay, there's 2 here that are often combined as one. So angle, side, angle, 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 side. They basically mean the same thing depending on which order you're looking at them in. Where both have 2 identical angles that are corresponding and a side that's equal, that's corresponding also. So the best way to learn these is to do. And what we want to do is, here in example 1, select a pair of congruent triangles from the diagrams below, giving a reason for your answer. Right, let's take a look. So first triangle here, we've got a 15 centimeter line, 95 degrees, which is opposite it, and then 50 degrees. Second triangle, we've got a 15 centimeter line, 95 degrees opposite, but 35 degrees here. Third triangle, we've got 18 centimeters opposite the 95 degrees and then 35 degrees here. Let's see, which ones are congruent? So which one are identical and similar? $95, $50, Yeah, I'm skeptical about this one on the far right, mainly because if we look, 95 degrees here and 18, they're opposite. 95 degrees here and the opposite is 15. 95 and 15 here is opposite each other. Yeah, so it can't be, I don't think it's the far right one, mainly because of the 18 centimeters. Okay, so it's not that, because of the 18 and 95 degrees being opposite angles. Wow, can it be these two though? Well, we have 95 degrees, 15, 15. They correspond. Let's see what they're saying. So remember, all the interior angles have to add up to 180. So what's 95 plus 50? That gets us 145. So 180 take away 145 here. This means this angle here is 35 degrees. That means this angle here is 50 degrees. So what it's saying is A to B, it corresponds to P to Q. Okay, so see how it's touching 50 degrees and 95 degrees. Then we have Q to R, 95 touching the 35 degrees, 95 touching the 35 degrees. So B to C and Q and R are going to be the same corresponding sides. And then lastly, yeah, we use yellow. A to C is going to be the same side as P to Q. Okay, but because we weren't given the interior angle, what we would say here is, well, therefore the proof will be angle, side. The side being the 15. Okay, the side being the 15. The two angles that are the same, well, going to be the 95 and the 35. Okay, so we don't quite have yeah, we've ran out of colors. We don't quite have the colors to highlight here. Actually, we may as well. Let's rub it all out. Okay, so we have the angle 95. All right, and then we can pick another color. Let's use cyan. Say the 50s are corresponding to each other. Okay, so that's a proof. We've got two angles that are identical, that are corresponding, and a side length that is in the 15, identical and corresponding. So the 15 was here. Okay, so tedious proof, but we got there in the end. Isosceles triangles. So two equal sides, but the third side is not equal. So equal with the dashed lines from line A to C and C to B. And so that means A and B at the base of the triangles are going to be the same angle. with the proof where we can draw a bisecting midline. That splits it into, I guess, two right angle triangles, which are mirror opposites of each other. So example 2, given that triangle ABD is congruent, so this is a congruent symbol, to triangle CBD, find the values of the pronumerals in the figure below. Well, let's use our color coordination here for simplicity. We know Z and D, they are mirrors of each other, so therefore we can say Z or Z is equal to 90 degrees. Since we've got an isosceles triangle here that's being mirrored. Okay, we can highlight that in yellow. Next one, remember the angle A and B proof from above. So if this side here is 40 degrees and we've got a mirror, that means Y will have to be 40 degrees too. So therefore, Y equals 40 degrees. Remember congruent, meaning both triangles are identical or the same. That is Y. And then lastly, we've got side length X to deal with. And we know side length X here is going to be 3 because the corresponding side length on the right, well, the right angle triangle is 3 centimeters. So yeah, that's it for example 2. Let's check out how many others we got. This is our last one. All right, so prove that triangle PQ is congruent to triangle RSQ. So PQS is a right angle in the top left. Triangle RSQ is a right angle triangle in the bottom right. So let's have a look at how we could go about proving it. So we know side length PQ are the same. So we can say PQ equals SR. And this was highlighted in blue. So this is what we call a side. So this side here is referring back to the proof tables where you can have a proof that if all 3 triangles have the same length and sides, they are the same. If 2 triangles have a side angle side, so a same side, a same angle and a same corresponding side, then they are also identical. Angle side angle, so 2 angles that are the same and a corresponding side length that are the same. Remember, everything has to be corresponding. They are also the same, so on and so forth, and a right angle triangle down below. Here they actually tell us it is a right angle. So we can say, let's use the color red. We've got a right angle. Why does that mix to black? Let's redo. Guess we just gotta be a little more cautious. So we've got ourselves a right angle there. Let's redo the blue line. Right, so we've established PQ is the same length as SR due to double dash. We can see here that angle we'll call it SPQ, or we could call it QPS. Doesn't really matter as long as it's probably better to be alphabetical, right? So A B C D F G H I J K L M N O P Q R S Yeah, no, don't worry about the alphabetical order. As long as P is in the middle, we know it's the angle P. So let's color coordinate this. So angle SPQ is equal to angle QRS. That's alphabetical. Where the vertex the vertex R is the right angle. And this is what we dub a R for right angle. And lastly, we've got a hypotenuse that is overlapping. So this middle hypotenuse of the triangle where we've got SQ equals QS. And we know this is a hypotenuse because it's the longest side and it's opposite the right angle. And so we can say this as the proof RHS. So therefore, triangle PQS is congruent to triangle RSQ because of RHS proof. Where do we get RHS from? R, H, and S, okay, as we see from above. So just continue to highlight. And so that's basically what each question will ask for congruence. It all comes back to the original table that we looked at up here, where you've got essentially four proofs that you can use, depending on the information they give you in the triangles. Okay, so that's all for exercise 10.2. Let me know if you have any questions.